Hello friends, welcome to 𝐘𝐥𝐬𝐬 classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor at Government Engineering College, Bilaspur, Chhattisgarh. In this video lecture series, I am teaching you Signals and Systems subject, and this will be the 42nd lecture of this series. If you have not watched till now, you can go, link is in the description box. And if you have not joined the Telegram group also, you can join there. More than thousands of students have joined there, and it is acting as a discussion forum. And if you have any doubt, you can discuss there. We are providing solutions and quiz link and all there only. So see, we have completed six module and we are now in the module number 7. In module 7 also we have completed two lectures in which I have dealt with DTFT, that is discrete time Fourier transform. That was Fourier transform only, but for discrete time domain. Now we will discuss about DFT in the today's lecture. So let's start the session. See, we'll start with our topic, that is discrete Fourier transform. Discrete Fourier transform. See, in short, it is called as DFT. DFT actually, what is DFT actually? So you can write that DFT, actually DFT, it converts. Okay. Obviously, we are using the word transform, means something is transforming. Okay. We have seen continuous time Fourier transform, Z transform, Laplace transform. Now we are seeing discrete Fourier transform. So DFT also converts. What it converts? Finite sequence of equally spaced samples. Okay. So now I think you must be understanding. It is finite sequence of equally spaced samples. The samples are equally spaced, है equally spaced samples of finite sequence. It is a finite sequence. Okay. Into, it will convert this type of signal, finite sequence of equally spaced samples, into same length. See, whatever length is there will convert in the same length. Okay. Same length sequence of equally spaced sample. Okay. So this will be function of frequency and this will be the function of time. Okay. So see, now what you are getting, DFT is nothing but a transformation from finite sequence of equally spaced sample in time domain to same length sequence of equally spaced in the frequency domain. Okay. And if we will take inverse DFT, IDFT. So obviously we are just doing the reverse part. We are doing the reverse part. Okay. So inverse DFT, if we'll do, we'll get the series. Okay. So inverse DFT will be a Fourier series. Okay. And it will use this the samples which are here and it will transform. So now we'll see some mathematical expression for DFT and then we'll try to understand. Okay. So see, for solving DFT means like this, value is there. So ultimately what will be there, n is equal to 0 to n minus 1, because see, finite samples are there. I told you in the definition only, I told you it will transform finite sequence of equally spaced sample. So we'll see, from n is equal to 0 to n minus 1, whatever your signal is there, this is f of n is there, and now we will do into e to the power minus j. Okay, earlier what you used to do, f of n into e to the power minus j omega n. Okay, omega is nothing but 2 pi by n, है ना, omega into n. This was there, but here k terms will also come. It will have the k terms, because see, the answer is coming in the k. So this is your value where k is nothing but 0, 1, 2, n minus 1. Okay, 0, 1, 2 to the till n minus 1. So this is the formula for see, your f of n is given in your question. It is a finite sequence f of n will be finite sequence of equally spaced samples. And what we'll do, we'll transform this f of n into this f of n into f of k, which will be also a same length sequence. What will be the length of the sequence? The same length sequence will be in the DFT also, and it will also have equally spaced. Okay, so this is the formula for DFT. This is the formula for DFT. F of k है ना is equal to whatever the n value will be there, 0 to n minus 1 will be there, f of n will be there into e to the power minus j omega n will be there into k terms will be there. This is the formula for f of k DFT. And if we will take IDFT, if we will take IDFT value, so what we will do, will take f of n here, f of n. So f of n is nothing but 0, k is equal to 0 to n minus 1, k is equal to 0 to n minus 1. Your f of k will be there because here k terms are there, so k we have taken f of k e to the power j omega n, so k will be there. Omega is nothing but 2 pi by n into n. So this is the formula. This is the formula for IDFT also. This is worth to be remembered, this formula. But see, you have also seen many formulas likewise only, so it is not a big task. Here you can see that n value will be, because here n values are there. See here ultimately the value will come in Fn. So n value will be 0, 1, 2, 2, okay, n minus 1. So this is the formula for DFT and IDFT. Now see, this the factor is e to the power j. I see in upside also e to the power j 2 pi by n is there. In downside also e to the power j 2 pi by n is there. So let's uh, let us assign this with a number or with a variable wn. So this is actually represented by this factor, and this factor is called as twiddle factor. Okay, so this factor is called as twiddle factor. So ultimately what you can write whenever you want to take DFT, so f of k is there, okay, and n is equal to 0 to n minus 1 will be there, f of n is there, and your e to the power minus j, like this values are there. So we can replace by twiddle factor. So we'll write here as twiddle factor only, e to the power sorry, not e to the power, sorry, w to the power w n is there, okay. Wn will represent e to the power j 2 pi n. So values were only k and n was remaining, so we'll write here minus kn. Okay, so likewise this is also the formula for DFT value calculation, where wn is nothing but e to the power j 2 pi by n. That is called as twiddle factor. So see, I think I have told you the definition. What is the definition of DFT? I told you the mathematical expression, I told you twiddle factor. Now by solving only we can understand. So we will try with one question. See, I am writing one question, we will try to solve it. So see, you have been given in the question, let's suppose f of n is 1, 2, 3 and 4, okay, and you have been asked to find the DFT of this signal, okay. So now you would have understood that, see, f of n is given, how it is a finite, obviously it is a finite, so it is a finite sequence of equally sampled, means equally spaced sample. N is equal to 1 is there, n is equal to 2, n is equal to 3, n is equal to 4. See, I will write here n is equal to 0 till n is equal to 3, n is equal to 1, n is equal to 2, n is equal to 3. So f of n is nothing but it is a finite sequence of equally spaced sample. Now we have to find out the DFT value. So DFT will also have the same length sequence of equally spaced sample with this formula. So we'll try with this formula. Let's try it. So we'll do it. Okay, find the DFT of this signal. How we'll do it? You know the formula is f of k. F of k is nothing but summation of n is equal to 0 to n minus 1. Okay, f of n will be there. Okay, e to the power minus j omega n was there. J first k you will write, omega means 2 pi by n is there, and into n is there. Simple, no very complex, only just simple. So now see, tell me, n minus 1, 0 to n minus 1 means how much it will be there. If you can write n is equal to 0 to 4 minus 1 is 3. Total n is nothing but 4. 4 values are given, so 4 minus 1 is 3. F of n is nothing but your 1, 2, 3, 4. Hai. This is your f of n, or you can write f of n only, no problem. For just reminding you that what is f of n, I have wrote in. You can also write here f of n. Okay, so I'll write here f of n. Okay, and then e to the power minus jk is there, 2 pi by n is nothing but 4 na, so 4 into n. So you can do, this is pi by 2. है ना. So see, e to the power minus j, see I will write here e to the power minus j k pi by 2 n. So you can also write as e to the power minus j pi by 2 and to the power k n. है ना. This you can do it. So e to the power minus j pi by 2 you can write cos pi by 2 minus j sin pi by 2. है ना. Cos pi by 2 is nothing but 0 and sin pi by 2 is nothing but 1. So it will be, value is minus j, and overall value will be j minus j to the power k n. So we can put here as summation of n is equal to 0 to 3, f of n will be there, and simply you can write minus 1 to the power k n. है ना. Okay, k what k value will be there? See, ultimately answer will come in k. So f of the k value will be changing. K is equal to 0, k is equal to 1, k is equal, because see, the value DFT value will come. See, f of n will take, if we will take DFT, we will get f of k only, and f of k value will be absolutely the same length sequence which will be in f of n. है ना. So obviously we will have the 4 length value only, so no problem is there with that. Now see, what we can do is, okay, we'll change the value of k and we'll see. For k is equal to, 0, what, for k is equal to 0, you can understand that I am speaking about the first value. है ना. For k is equal to 1, second value, k is equal to 2, and k is equal to 3, like this value I am going on. So for k is equal to 0, you can write f of 0. Okay, and here n is equal to 0 to 3, f of n is there. Okay, and minus 1 to the power 0 n. So you can write here is summation of n is equal to 0 to 3 f of n. So ultimately what it can be written as f of 0, f of 1, f of 2, f of 3. And this value, as you know that the values were 1, 2, 3, 4. So you can write 1 plus 2 plus 3 plus 4. So ultimately you will get 4 plus 3 7, 7 plus 2 9, 9 plus 1 10. So ultimately f of 0 you got 10. So see, you have got this value is 10. Okay, now next value is f of 1. So f of 1 will write for k is equal to 1, what will see, f of 1. Okay, so here we'll write n is equal to 0 to n minus 1, and see, we'll write f of n value is there, minus 1 to the power minus j to the power k n was given. So k is 1, so we'll write here minus j to the power n. So ultimately what you'll get, f of 0 value will be there, minus j to the power 0, plus f of 1 value will be there, minus j to the power 1, plus f of 2 j minus j to the power 2, plus f of 3 value will be there minus j to the power 3. So ultimately what value you will get, see, you can keep the values and you can get, I'll write the direct answer minus 2 plus 2j. Okay, this is the direct answer of this, you can solve it. So now f of 2 value, for f of 2 value what will be there, n is equal to 0 to 3, f of n will be there. Okay, f of n minus j to the power kn was there, so 2 into n is there. Now like this value will come, so ultimately f of 0 minus j to the power 2 into 0 plus f of 1 value will be there, minus j to the power 2 into 1, and like this, so on it will go on, means till f of 3 value will go on, and so this answer would come minus 2. So ultimately, see, f of 1 answer came, f of 1 is nothing but minus 2 plus 2j. So I will write with yellow, minus 2 plus 2j. Okay, next value what came, next value is minus 2 came, last value is nothing but f of 3, value. So f of 3 value will be n is equal to 0 to n minus 1, so n is equal to 3, f of n is there, and minus j to the power 3n is there. Okay, so see, if you will put the values and you will calculate, you will get minus 2 minus 2j, this value you will get. So ultimately you have got the answers. Next value will be f3 will be minus 2 minus 2j. So see, what was given in the question. In question, you have been given f of n, a finite sampled value, and you need to calculate the DFT value. DFT is the transformation in of the same value of f of n of finite sample value in the frequency domain. This is the f of k is in the frequency domain, f of n is in the time domain. So ultimately we are transforming it, but for the finite, and in the frequency also we are getting the finite. This is the thing which we get in DFT. So ultimately I will write here uh, f of n is 1 2 1 2 3 4. This value would got DFT value is nothing but 10 है ना, minus 2 plus 2j, minus 2 and minus 2 minus 2j. See, I am writing why this expression again, because I wanted to draw some conclusion. See, what conclusion can be drawn? See, the first term in the DFT value, in the first term was nothing but, f of 0 was nothing but f of 0 plus f of 1 plus f of 2 plus f of 3. Ultimately it is a sum of all the term, है ना. So I am telling you the shortcut to find the DFT, not to go for this much lengthy calculation. The shortcut will be, the first shortcut will be, if you need to calculate the f of 0 value. F of 0 value, see, it is the sum of all the terms. So f of in the this time domain, we will calculate f of 1, f of 2, f of 3. This all value will calculate f of 0. See, f of 0 will start from f of 0, and then f of 1, f of 2, f of 3. Don't confuse with, see sir, f of 0 is there, f of 0, can we cross it? Arey bhai, what you are telling? This is in frequency domain. If I will tell you, this is DFT value, है ना? So this is in frequency domain, and these all values are in time domain, है ना? These all are in time domain. So what we are doing, we are adding all the values to get the f of 0 in the frequency domain. This you need to remember. So we'll see, it will go on. Okay, next what we'll do, next shortcut what you can understand. See, you can see this expression minus 2 plus 2j, and this expression minus 2 minus 2j. Ultimately it is a one and each other are conjugate of each other. So the second conclusion what we can observe is f of k is nothing but is equal to f of abstract n minus k, See, if you'll observe here, this was your f of 1, है ना? This was your f of 0, this was f of 1, f2, f3. So f of 1 is nothing but f of conjugate n minus k. So it is k, it was k, and total n is 4. 4 minus 1 is nothing but 3. So f of conjugate of 3. Can you see? F of 3 is this. If you'll do this conjugate, you'll get this one. So ultimately, what I am telling you, that always in the DFT value we have seen this observation, that always f of k will be equal to f of conjugate of n minus k. So this is very important for, these shortcuts are very important for competitive exams, because in competitive exam you won't go for this much long calculations. You need to follow the shortcuts. So if you'll understand the shortcuts, then only you can it will be remembered by you. Otherwise you have to memorize, and then you will forget also. Third conclusion what we can observe is, see, this value was there, see, f of n by 2, okay, f of n by 2, f of n by 2 will always equal to f of 0 minus f of 1 plus f of 2 minus f of 3 and so on. Means 1, there will be 1 plus sign, minus sign, plus sign, minus sign, and so on. So see, you can observe this. See, I will tell you, f of what is n here? Here n is 4. So 4 by 2 is nothing but 2. F of 2 is nothing but the first term minus second term plus third term minus fourth term, like this. What is the first, second, third, fourth? This was your f of n. This is your f of 0. So we'll do 1 minus 2 plus 3 minus 4. So see, the values will be 1 minus 2 is minus 1, minus 1 plus 3 is 2, 2 minus 4 is minus 2. Can you see the answer is minus 2 only? Where is this? K is equal to 2. See, minus 2. So see, whenever you have been asked to find the DFT value for 4 sampled value, see, first value is very easy, just add all the values of fn, so you will get first value, है ना. Third value is very easy, f plus minus means f of 2 value is very easy to calculate. So minus 2 also, this, see, I will write here, this value was very easy, just add all things. This value is very easy, plus 1 plus f of 0 minus f of 1 plus f of 2 minus f of 3 plus f of 4 minus f of 5. Like this value it will go on, alternate. So this is very easy to calculate from f of n only. No need to go for mathematical operation also. Okay. See, this term is the conjugate of this term. This term is the conjugate of this term. So this term, if one term can be found out, then other term can be also found out. So no need to find. Only for one term we need to calculate the formula. Only for one term we need to calculate the formula. It is very easy to calculate. See, now we'll see. I'll tell you. I'll give you one more question, and we'll try to solve that. How many things you can try? See, let's suppose you have been given f of n is nothing but 1, 1, 1, 1, 1, 1, 1, 1. Let's suppose this value is given, है ना? And find the DFT of this signal, है ना? Of this signal. Now how we have to do? Okay, see, by using shortcut I will tell you. See, f of 0 you can find out. F of 0 is nothing but all values are added. So ultimately all values are added, it will be 8 only. No problem with that. है ना? See, f of n is like this. So we'll get, I'll mark here, or okay, f of I'll mark here like this. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 values will come. Okay, no problem. So f of 0 value came. This value though came from without doing anything. F of n by 2, n is nothing but 8. So f of 4 also value can be came. So 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. So ultimately answer will be 0. So ultimately f of 0, f of 1, f of 2, f of 3, f of 3, sorry, f0, f1, f2, f3, f4. f4 value came is 0. So this value also came without doing any mathematical operation, just a simple operation we have done. Okay, so ultimately now f of k value will be equal to f of conjugate, okay, f of conjugate n minus k. So ultimately if you'll see f of if you'll see f of one value, okay, 0 value so we have calculated, f of one value will be nothing but f of conjugate of 8 minus 1 will be 7. So f of conjugate 7 value we can, both are equal. F of 2 value will be, f of 2 value will be f of conjugate 8 minus 2 will be 6. So these values are equal. F of 3 value will be equal to f of conjugate 8 minus 3 is 5. Okay, and f4 is f4 only. So ultimately these value will be equal to this value f of conjugate 7 8. Okay, so ultimately maybe you can also do like this, that f of 7 value will be nothing but f of conjugate of 1 value. Obviously f of 6 value will be equal to f of conjugate of 2 value. Conjugate can be go to the left hand side also, no problem. F of 5 will be f of conjugate of f of 3 value. So ultimately if at all for this full all value, only what you need to find out is f of 1 2 3. Just apply the formula for f of 1, f of 2, f of 3. These value only, just evaluate the formula. These value will be the simple conjugate of these value, and you will get the answer very easy. So finding DFT is not at all tough. Finding DFT is not at all tough. If you can solve by mathematical operation, then okay. For mains exam, for conventional exam, you can solve by this formula, by this mathematical full derivation type. And for objective type of question, you can directly put the formula shortcuts and you can get the answer. Now we'll go for next type. Like, see, we have seen how to take DFT, and we have seen why we are taking DFT. So okay, we have seen some questions also. Now we'll go for one more type, in this only property we'll see, that is circular convolution. So circular convolution, okay. So first of all, if in your mind you'll think that, sir, why we are going for circular convolution when we have seen convolution in module 2 also. We have seen so much convolution techniques to find the convolution, tabular method also we have seen, mathematical, graphical, everything we have seen earlier. So why we are going for this circular convolution? So I will tell you. See, circular means, you have seen watch, here it is 12. The hand, hour hand will go on like this, or minute hand will go on like this, and again when it will come to 12, again it will start from 1. So circular is used when something is repeating again and again, means periodic. Ultimately for periodic we can use this type of thing. So as you know that DFT sequence, DFT sequence is periodic, is periodic. So here we will use convolution of circular. Here we will use convolution of circular. So see how it is done. We will see. See, values are given. Let's suppose f of n values are given. Let's suppose 4 3 2 1. This value is given. Okay. Now this value is, I think, linear. If you want to represent it in the circular, how can you represent? Make a circle. First step, divide the circle circumference into the n equal part. Like here, how much n values are there? Total 4 values are there. So divide it in the 4 equal parts. Okay. First step will be your making the circle and dividing the circle circumference into the n equal parts. Now what you can do, you can put the value. See, this is the n is equal to 0 value. This you can keep n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. Okay, what is n is equal to 0 value? That is 4. Here it is 3, here it is 2, and here it is 1. So this is the representation of this f of n if it is repeating, because what we are seeing, see, whenever f of n is transformed to f of k is nothing but dft of f of n. So f of n was periodic and discrete. Discrete is there, but it was periodic. You should remember that DFT is used for discrete time signal and periodic signals. Then only you can transform from DFT tool, DFT tool. And now what we are getting here, see, f of k, what we were getting, you can remember the questions. We were getting the almost same length sequence, we were getting, and f of k it is also different values were there, so it was also discrete. I will write here discrete and periodic. This was also discrete. Okay, discrete values are there in f of k, and this all values are also repeating, so this value is also periodic. So ultimately for DFT, discrete periodic signal is transformed in frequency also, discrete and periodic only, but it will in frequency. So see, ultimately f of n is given. I have represented that f of n in the circular value. Okay, now if I'll tell you, if I need to do f of n minus 1, how you will do f of n? Okay, you now you understood that how to represent f of n here. How to represent f of n minus 1? Then I will tell you just what you need to do. For f of n minus 1 means in the time domain we are shifting towards right hand side. So what we'll do, we'll do like this. The values were there, and just we need to shift in the linear scale. If we are shifting the right hand side, in the circular we will shift like this. Okay, so f of n minus 1, now f of n is equal to 0 will come here. N is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, because it has been shifted. So now will value is 4 here, 3, 2 and 1. Okay, you can understand that after this all value n is equal to 0, 1, 2, 3, 4, it is again repeating and repeating and repeating. So see, these values f of n minus 1. Now if I'll ask you, then please plot f of minus n. How you will plot? F of n is same only. So now you'll do, again circle will be there, 4 equal parts will be there. Now for minus n, see, in the linear scale what we were doing, just taking mirror image from y axis, hai na? So like this here na, this horizontal portion will remain same. So here n is equal to what f of n was, n is equal to 0 and n is equal to 2. So n is equal to 0 and n is equal to 2 will remain the same. Okay, so we'll have 4 4 3 2 1 na? So 4 and 2 is the same only. Just flip it, flip top to bottom, bottom to top. Like here everything was same, just we were shifting from just taking mirror image like this. Take water image, you can say take water image. So here n is equal to 1 will come here, and n is equal to 3 will come here. So see, 4 3 2 1, so 3 2 1. Now you can see. So ultimately what I have told you from this expression is circular. Why we are doing circular convolution? Because in DFT type of transformation, the signals are discrete and periodic, first of all. So for this type of periodic and discrete, what we can do is we can put it in the circle and we can solve. Because see, either in the linear form also you can solve, but the value will come in the very shortest form. So we'll try with one or two question, then only you'll able to understand the concept. So we'll try one question. See, f of n was given to you. Let's suppose 1, 2, 3, 4, and h of n was given to you. Let's suppose 4, 3, 2, 1. Okay, and you have been asked to find the circular convolution. You need to find the circular convolution of this signal. Okay, see, you can also find linear convolution. You'll get some different answer. First of all, we will find circular convolution, then I will tell you how we'll solve it from linear, and we can get this answer also, and what is the relation between them. So I will tell you, first of all, we will find the circular convolution. See, convolution, you know that ultimately convolution is nothing but k is equal to minus infinite to infinite value. F of k values will be there, h of n minus k value will be there, है ना. Just what you need to do, both signals are there, you need to change the domain, you need to take reverse of h of n, and then you need to shift by k. This we have studied in the module 2 also, in LTI systems also. If you have difficulty, please go and watch that video. Now see, this can be done from circular convolution also, no problem with that, because we know how to reverse in circular also, and we know how to shift in the circular also, no problem with that, no problem. So what we'll do, first of all, we'll make f of n, because fk will be same only, fk will not do anything. We need to shift h of k only, na. H of, first of all, we'll make k, will reverse, and then we'll shift to the with n, है ना, to the n values. So f of k will be same. So what we'll do, we'll plot like f of n value will be there. First of all, plot f of n. How much partition we need to do? N is equal to 4 is there, so total 4 partition. The values will be 1, 2, 3, and 4. है ना? F of n value 1, 2, 3, 4 I have put it here. So I can write here f of n, or I can write here f of k, because we have changed the domain. Now you can also plot h of k also, है ना? H of k also, like this we can plot. So it was 4, 3, 2, 1, है ना? This is your h of k. But do we need h of k? No sir, we need, first of all, we need to reverse it, h of minus k also we need. So what we can do, we need h of minus k, है ना. We'll do here, we'll mark it, h of minus k means keeping the horizontal value, just reversing the upper, top and bottom value. So we'll get like this. This is h of k. But do we need h of minus k? Yes sir, we need h of minus k, but we also need the shifting also. So first, let's suppose, see, first value for this value will come, this value will come y of n, है ना. Ultimately answer, so ultimately n values will see, for y of 0 what answer will come. Obviously k is equal to minus infinite to infinite, f of k will be there, h of n minus k. So 0 minus k is nothing but h of minus k. So ultimately f of k into h of minus k, for k is equal to minus infinite to infinite. So ultimately what you can do is, just you need to multiply f of k into h of minus k with all values. So multiplication will happen with the same values, like top values will multiply with top values, है ना. This value will multiply with this value, like this value will come. So ultimately if I'll write here 2 into 1, है ना, plus this 1 into 4, so 1 into 4 plus this 4 into 3, है ना, 4 into 3 plus 3 into 2, है ना, plus 3 into 2. So ultimately 2 plus 4 plus 12 plus 3 plus into 2, 6. So ultimately what answer came, 4 plus 2, 6, 6 plus 6, 12, 12 plus 12, 24. So answer is nothing but 24. So this is y of 0. Y of 0 you have calculated by just doing the multiplication of f of k into h of minus k. No problem with that. Now for the second term, means y of one value, what we need to do is, k is equal to minus infinite to infinite value is there, f of k value will be there, h of 1 minus k will be there, h of 1. Now see, your f of k was there, f of k was there, nothing but 4, 3, 2, 1. This was your f of k, है ना. Now you have to do h of 1 minus k. Actually you know h of minus k. Can you do like this, minus k plus k minus 1, like this. So what you will get, h of minus k plus 1, है ना, what we need here. So what we are doing, first we are doing h of minus k. We already have h of minus k with us. This is of h of minus k. Just we need to do minus 1, means we need to shift. So ultimately, you know that if you will do linear shifting in the right hand side in the circular convolution, we need to do like this. So I'll plot here h of 1 minus k. H of 1 minus k is nothing but just will do I'll plot here, will do the shifting like this. Okay, we'll do shifting. So what will happen? 4 1 2 3 na. So 4 1 2 3 I will put here, 4 1 2 3. This is your h of 1 minus k. Simple, sir. Now what you are doing, f of k into h of 1 minus k, you are multiplying and adding. So every values will be multiplied with same one another and will be added. So ultimately, see, I will write here as 3 into 4 plus 4 into 3 plus 2 into 1 plus 2 into 1 है ना. So ultimately you will get 12 plus 12 plus 2 plus 2. So 12 plus 12, 24 value. Okay. Once check, f of k is nothing. F of k is, I think, 1 2 3 4. I have made mistake. Okay, I'll do it. Sorry. I'll put here. I'll put here. Okay. We'll mark it 1 2 3 4. No problem. Okay, so I'll write here 1 2 3 4. So some calculation will change. 2 into 4 will come 2 into 4, and here 1 into 3 will come 1 into 3, plus here will come 4 into 2 4 into 2, and plus here 3 into 1 will come 3 into 1. So 2 4s are 8 will come, 1 into 3 is 3 only, and 2 into 4 8 value, 3 into 3 8 plus 8 16, 16 plus 6 value will come 22 value. So ultimately answer of y of 1 will be 22 है ना. Y of 1 will be, so we have got another, let's suppose we'll do next value है ना. Next value, y of 2 value will be there. So it is nothing but k is equal to minus infinite to infinite, f of k value will be there. Now I will tell you, I will put the values. If you will not understand, just take the videos back and see what I am doing. So 1 2 3 4, this is nothing but f of k value will be there, h of 2 minus k. So h of 1 minus k is already we have seen here. Just h of 2 minus k, just again shifting. So again you shift here. So 3 4 1 2 is there na, 3 4 1 2. So I'll do here, 3 4 1 2. Now you can just do multiplication, this. So 2 into 3 will be there. Now 1 into 2 will be there, 1 into 2, plus 4 into 1 will be there, 4 into 1 will be there, and 3 into 4 will be there, 3 into 4. Okay, so we'll get 3 into 2 6, plus 2 ones are 2, plus 4 plus 12. So what value will be there? 6 plus 2 8, 8 plus 4 12, 12 plus 12 24. So ultimately y of 3 also, y of 2 value also we got 24. Last y of 3 value will get, see, y of 3 value will get. So what we'll do, y of 3, k is equal to minus infinite to infinite, f of k value will be there, h of 3 minus k. So obviously you know this value, 1 2 3 4 है ना. This is your f of k value है ना. h of 3 minus k, how you will calculate? Just again this shifting only, we'll do this shifting only. So what we'll do, 2 3 4 1. So we'll write 2 3 4 1 है ना. And now see, you can just multiply all the values, 2 into 2 plus 1 into 1. Okay, 1 into 1 plus 4 into 4, 4 into 4 plus 3 into 3 and 3 into 3. So what will get? 4 plus 1 plus 16 plus 9. So we'll get 4 plus 1 5, 5 plus 9 is 14, 14 plus 16 is 30. So ultimately 30 will get. So final what answer we got is C, f of f of uh, sorry what was your f of n was nothing but 1 2 3 4 है ना. H of n was nothing but 4 3 2 1, and you need to find the circular convolution of this है ना. So what answer you got is 24 22 24 and 30. Is that is see, this is the value which you got output. And if you'll solve by tabular method, see, if you'll solve by tabular method, you'll see 1 2 3 4 was there, and 4 3 2 1 है ना, 4 3 2 1 value are there. You'll see 4 2 is 8, 4 3 is 12, 4 4 is 16, and 3 3 is 6, 3 3 is 9, 3 4 is 12, and 2 2 to the 4, 2 3 is 6, 2 4 is 8, and 1 2 3 4. So see the values which you will get है ना. Okay, so what you will get 4, and then we will get 8 plus 3 11 plus 12 plus 6 is 18 plus is 2 is 20, and then you'll get 4 plus 1 5, 5 plus 9 14, 14 plus 16 is 30, and then you'll get 12 plus 6 18 plus 2 20, and then again you'll get 8 plus 3 11, and then you'll get 4. See, like this value will get when you'll do linear convolution. This y of n, when you will get, when you will do linear convolution. So and it will have the value 1 2 3 4 5 6 7, 7 values were there. If you have remembered, if this length was L, this was length was M, so this length this y of n length was L plus M minus 1 है ना. So 4 plus 4 8 minus 1 7. So ultimately this length for linear convolution it was 7, but for circular convolution, if it is having the four values, if it is having the four values, it will also have the four values only, because it is DFT values. You remember that DFT value will have the same sequence in the output. So see what we are doing, are we having some relationship between circular or that linear? Can we draw answers from linear also? So yes, you can draw. If you can, if you are suitable or comfortable for finding the linear convolution, just find it and then see what you can do. This value है ना, first of all, just how many values are there? 1 2 3 4 5 6 7, 7 values are there, which is half value. See, 3 values are here, 3 values are here after this 30. So what we can do is, we can this value we can make a line, means imaginary line will be there. This 4 value and this value will be added, then what you will get? 24 है ना. Okay, this value will be added with this value, what you will get? 22. If this value will be added with this value, what you will get is 24, and this value will be 30 only. Is it the same thing which we have calculated in the circular convolution? 24 22 24 30. So this is the method that can be calculated from linear convolution also, and from circular convolution also. So I have told you the long cut method to find the circular convolution. Okay, so I have told you this much. So today we'll close with this thing. We'll try that the next lecture will be the last lecture for this whole series. We'll try to complete the properties of DFT, and we'll see what is group delay and phase delay. And in brief, I will tell you fast Fourier transform, because fast Fourier transform, this will all will come in actually DSP portion. DSP portion will consist of the filters, है ना, the filters one, pole zero concept is there, and it will have again in detail DFT and FFT value. FFT is the fast Fourier transform. Actually DFT, how we are doing, long cut method, FFT is the fast Fourier transform. So another sir will be there. He will be dealing with the engineering services DSP syllabus, and this fast Fourier transform also he will be dealing with that. IIR filter, FIR filters are all areas of digital signal processing. So some small portions are there in your signals also. So that sir will deal with that. So today we'll close the class, and maybe I will try my level best to complete my portion, which I have completed almost 99.99%. I have completed. I will complete, and okay, till then we'll see, we'll meet you in the next lecture. Till then, tata, bye bye, see you. And if you like the video, please hit the like button, share it with the needy students, and if subscribe it if you have not subscribed it. Okay, tata, bye bye, see you. Have a good day. Jai Hind.